Hi everyone, thanks a lot for joining us today for a quick workshop on how to use Redstone oracles on Subnets and the C-Chain of Avalanche. My name is Marcin. I'm a COO at Redstone, so leading BD and making sure that the company runs forward. And
I'm Jakub, I'm the founder. I'm also like a technical. And yeah, so I'm mostly responsible for the software design and also like trying to push the product forward. And today we'll be talking about how to use our oracles in the Subnets ecosystem, which I'm very excited about. And I think it's amazing innovation coming from the Avalanche.
Yeah, so maybe like to start with, I'm going to tell you a few things why it's important that you understand like how Redstone works. So as probably majority of you know, an oracle is an intermediary layer that aggregates data from various sources, such as centralized exchanges, price aggregators, on-chain data, various sources, and then delivers that to target blockchain. When oracles were designed first, like in 2017, 16, 18, like that was almost the world of Ethereum only. Like right now we're on an Avalanche conference, so it shows that right now it's a cross-chain environment, and the future is going to be probably like even like dedicated subnets for specific use cases. So in order for an oracle to work efficiently in such a model, you have to create something that is replicable for many ecosystems. It's not like just status quo how it is right now, and you can sit like this. You have to be flexible, nimble, and innovative as you go. So we are no strangers to the ecosystem. Last year, I and Jakub were over here also presenting about Redstone. Over then, we had just one model that you could consume data. We also listened to the developers, so we added like 2 new models. So today, we are going to present also some other aspects over there. And also, we are grateful enough for the Avalanche ecosystem, like Avalanche people to support us on the way, because Emin is one of our close supporter, as well as the whole Avalanche team, and we had a kind of a good success with Delta Prime launching today. So no further ado, I'm going to talk now about the traditional Oracle model. So as you know, like Chainlink is the main incumbent in the space that delivered fantastic job over the years protecting like your data on Ethereum and other blockchains, but they are slow to innovate. Of course, if you're such big and you provide data for established protocols, you're less innovative and less quick to respond to the trends that are emerging. So in the traditional model, there are data provider nodes that take the same data and push to many ecosystems. So like Ethereum, Avalanche, Polkadot, and so on and so forth. So you can quickly understand that you have to multiply the cost of updates of the same asset, of the same price feed on multiple chains. And that's fine as long as the big player subsidizes that, but it's not the world that you can have like entire time, right? At one point, someone has to pay. You have to create like a healthy business model that is sustainable. So this data provider, so these nodes of data providers push data on chain, for example, in Ethereum to a dedicated smart contract, and then an application, for example, Aave, can from its smart contract read the data that is already on the chain and execute any transaction that user has. Pretty simple. It's not like any like rocket science, but quite limited when it comes to diversity of data feeds because it's expensive, so you cannot provide like more sophisticated assets. Frequency. So if any of you has used Chainlink and requested them, for example, to do something like as low latency or super fast, it's usually not an option because of the update costs. And last but not least, like going to new ecosystems. So for example, for subnets is like a big hurdle for them. So they're not going to deploy like right away. You have to negotiate a contract and so on and so forth. So now Jakub is going to tell a bit more about us and how we work.
Yeah, so the current status quo and Chainlink did an amazing job. The solution is very stable, very secure, but also in the world where we got multiple chains, not only the L1s, L2s, but let's imagine a plethora of the subnets. We need to have like more scalable and versatile solution. So that's why we decided to build a modular system when the data, instead of being pushed directly to the target chain, it goes first to our data delivery network, which is a highly distributed and decentralized layer built on top of few other chains. Like we use Streamer, the centralized PubSub network. We also use Arweave for the persistent storage. And we got open source lightweight Redstone gateway nodes just to propagate the data across the data delivery network. So all of the data from the providers goes to the delivery network, and then the dApp, whenever it's needed, take a data packet from that network and attach it to a user transaction. Therefore, the data is transmitted to the on-chain environment only when required, so that's the on-demand model. So it's like super efficient. You can have updates in the data delivery network happening, so currently in production every 10 seconds, but we are experimenting with sub-second updates. And this low latency data could be easily injected to any of the target chains through the dApp. So as we mentioned, we are in production since January with Delta Prime protocol. We are like very excited with their success and the extremely fast pace of the TVL growth. And we managed to facilitate more than 30,000 transactions. All of the data is publicly available. And the models was very successful and robust. Even during these crazy times of the DPEG, the solutions remain robust and stable. And as Marcin briefly mentioned, we focus on being very flexible and versatile. So instead of offering a single model to integrate, we, after talking to many projects, focus on building 3 main product lines. So the first one, the core model that is deployed in production by a few protocols, takes the data from the data delivery network and injects it into a user transaction. Therefore, it's very efficient, and also out of the box, it could be used on multiple chains without the need to change a single line in the smart contract code. Also, there is no need for any extra infrastructure. The integration, and I will show it later, requires just to use our library and connect the library both to smart contracts and to the dApp frontend. We are also working, that's exciting stuff, on the X model, which is inspired by the cooperation with the GMX team. And in that model, the goal is to protect against any kind of a front running. So let's imagine that the user interacts with a perpetual protocol like JMX. So first, a user needs to record on chain a request for a transaction to be processed, like opening a position or increasing a position. And then in the very next block, this request is settled, but with the price coming from the time when the request was mined on chain. So there is no possibility for a user to know a market price in advance and try to raise the Oracle update, because the price is only provided and delivered on chain after a user is committed to a transaction. So this could be more and more important for the derivatives protocol, for the such as options, perpetual, any kind of a leverage. So any use case which is very time sensitive and it could be front run can benefit from that model for security. Also, we provided a classic model. And as we mentioned, the space is mature and obviously chaining dominates it. So some of the protocols are a bit hesitant to modify the code that is already like well audited, well tested, and used by multiple users. So we decided to work on a classic model that offers the same interface, but with the updated core layer. So you can benefit from low latency data from a large number of assets, but use the same familiar interface without any changes to your code.
So maybe if I can add to the previous one, one thing that I would like you to remember after this session is when you think about Chainlink, you are pretty well aware that the condition updates are known. So there is a heartbeat for a specific token, and there's a deviation threshold that you're willing to accept. but it's not you as the dApp willing to accept, it's the ecosystem on which your dApp is deployed. So it's specific for Avalanche, it's specific for Ethereum, it's specific for anything else. So if you as a dApp has another request, you have to adjust to everyone else in the line, right? Whereas in our model, thanks to this data delivery network and keeping the same security of the destination chain, because each data package is signed, we can truly like adapt to the needs of a dApp. So whether it's like in a core model X or the classic one.
It's more like having your, let's say, like a home version of Chainlink when you can play with all of the parameters and easily deploy the same infrastructure, for example, on a subnet. Okay, so that's the time to look at some code. I'm just curious, will any of you will be following, trying to implement that? Is there any appetite for you to work on a laptop? I know it's not the best timing, because yesterday we got this party. But, okay, so I will show you the code. No need to.
So is there a single person willing to follow the code? No?
Right.
Okay.
Yeah.
Okay.
Does it work for you guys? Okay, so if you're like fully rested at home, would like to play with our oracles, that's the place to take a look. It will probably take you like 10 or 15 minutes to deploy both models. We try to make it super easy for you, but let me just provide you like a top level overview of what's going to happen here. So we are having just 3 contracts in this demo. The first one is pretty trivial. It's just a token. We call them USD, as it's going to mimic the USD coin. Ah, sorry. Yeah, of course. Is it better? Can you read? Perfect. Nothing fancy happening here. Just a coin you can mint and get extremely rich fast, like in blockchains. Then we got two dexes, one dedicated to the core model and one dedicated to the classic model. So let's start with the core model, which is more advanced and already in production. And in order to use it, maybe let's start with the logic of a DEX, which is also trivial. You just connect it to a dedicated token, and then you can change your AVAX to this USD based on the current price of AVAX. So it's like let's say the simplest possible version of GMX you can code in 5 minutes. Obviously, please don't deploy that into production. It may require some upgrades, but the idea is the contract creator connects that to a token. He can deploy tokens and start selling that tokens to public audience, collecting fees in the native network token. So it could be AVAX, it could be any of the subnet token. And after this transaction, the owner is entitled to withdraw the funds. So probably the easiest way to bootstrap a DEX in an ecosystem. And what's interesting here, in order to get this benefit of Oracle connection, you basically need to connect your contract to our base contract. We make them like super easy to use. So this one uses the data from our main demo. It covers like more than 1,000 assets. And after extending that base contract, you have access to one very important method here. It's on the bottom. It's get Oracle numeric value from transaction. So what's happening? The data is injected in the transaction. Behind the scenes, the logic included in the base contract verifies all of the signatures. So the data comes from multiple data providers, medianize the information, also checks all of the timestamps, and then make the data available within a contract. All right. Let me maybe switch to the code. Maybe let me try to deploy. So also we got like deployment scripts. So it's going to deploy these 3 contracts, like the USD, DEX Core and DEX Classic that I'm going to show you later. And after that, we can try to execute a simple script. Maybe I'll also show you the code, what's happening there. So first, we are pushing some USD stable coins to the contract, and then we are executing the swap. And as you may see, then the original balance of, let's say, 100 USD stable coins was updated as I think at the moment, slightly more than 17 USD coins were sent back for 1 AVAX. And the total cost of a transaction was 50,000. So what's also important, we work a lot on optimizing the cost. So the overhead of using our Oracle data is really minimal. So in that case, if you try to run the transaction without access to data, the difference will be only about like 11,000 gas units, which is like very low for having the ability to consume the most up-to-date prices. All right. Let me also share with you what's necessary on the front end or the script side in order to use our core model. So the depositing USD is pretty trivial. It's probably, if anyone has any contact with the Solidity or building dApps, that's obvious. But the interesting part is in here when we need to wrap a contract in order for our SDK to automatically inject the prices. We also try to keep it easy for developers, so you can use our wrapper, which is built on top of the ethers.js, and then specify the data service ID, as we got multiple services providing different kinds of data. This one provides like more than 1,000 assets. You can also define how many different unique signers do you require for your contract in order to verify data. So in the demo mode, we can start with a single signer, but in production, obviously, it's better to have multiple data providers. So we got the redundancy, security, and the decentralization of data aggregation. And you also specified what kind of data is going to be consumed by your contract, so we can reduce the amount of information injected to a user transaction payload. Also, you can connect to any of our gateways. So this is a demo gateway, but the gateway code is fully open source, so anyone can spin off their own gateways and is connected to the decentralized delivery network. So after wrapping a contract, you simply execute a method, like with any other library, and the data is automatically injected to a transaction. Let me then tell you a few words about the classic model. So the classic contract doesn't require to use any of our libraries. And it directly utilizes the probably most popular interface for data consumption, which comes from chaining, and it's the aggregator interface. So all of the major solutions do not need to modify their code, for example, migrating to subnets. So in a constructor, we need to provide some details when your price fit contract is deployed, and then you can directly consume the data in the same way as is implemented in most of the contracts, most popular contracts on chain. So just taking the data from the aggregated interface and getting the price. Okay, maybe I will also quickly show like how it works in that way. So we get a fresh contract, we are going to deposit some dollars there, and we are going to access the data, this time coming from this pre-deployed price feed contract. Okay. So going back to the code, you may ask like how the data is available on chain in that situation. So if you are going to follow the tutorial, so in first step we show you how to deploy your own subnet, which in my view is like super easy. Probably will take you like 5 minutes. The Avalanche core team done a really amazing job. So all of the steps are described here. After that, you just need to get your RPC endpoint, put it in some configuration file. You also need to have the address of a pre-founded account with some tokens. Where's this? Just trying to slide it down. Doesn't work.
Seems like computer froze for a moment. So maybe let's take a chance. Do you have any questions so far? Like anything that hasn't been so clear?
Oh, that's interesting. That's the fun of having live demo. Okay. Okay, so let me tell you like how the data is magically injected to the contracts that are deployed on the subnet. So for that, we need a relayer module, and the task for a relayer is to connect to our data delivery network, take all of the packages, and then push it on chain, but you can define all of the rules when and how the data is going to be injected on chain. So actually in Subnet, it means that you can have like your own version of the, let's say like a chaining infrastructure, and you define the deviation threshold, you define the heartbeat, you can also configure the injection based on the events happening in your contract, and then the data is populated to a price feed contract, and then consumed in an easy way from the storage by your contracts. Are there any questions to the model? Was anything unclear, or do you want to ask about how it works, etc.?
Is there anyone who is planning to launch a subnet over here? Raise your hand if so. Okay. So maybe any questions specific to subnets, because like this setup is fantastic for doing so, because then it's like step by step explained, and as mentioned before, it's instead of like ecosystem first approach, it's DApp first approach. So you being the cook master, you can specify like quite a lot of specifications in the whole integration. All right, I think there are no questions.
Okay, sure. Set it.
It's not like exactly related to the technical thing, but I can imagine that Chainlink can like make money when they like talk with blockchains to like subsidize the gas, and also maybe like a profit margin for them. How you guys are going to like make money for yourself to be sustainable?
Mm-hmm. Absolutely. So we got to approach with our pricing model. With the core model, the beauty of that is that we got a full visibility when the data is consumed. So it's like an on-demand model. We see what transactions are taking the data, and therefore we can have a very flexible pricing solution that you as a protocol are only paying for the transactions that were appended with the price, that actually consume the price, and then you can connect also to your protocol business model and have a simple revenue share model when you collect fees when a user is making a transaction using a protocol, and a small part of the fees goes back to a Oracle provider. So Oracle is like an extra service that's going to take a very small cut of your fees, and we can quite easily calculate that and reconcile after, let's say, every quarter, because all of the data is publicly available on chain. With the relayer model, it depends, let's say, on the appetite for a protocol to either maintain their own relayer infrastructure, which is fully open source and anyone can run it, deploy multiple nodes, etc. We well tested that in that environment with the redundant nodes. So in that case, we only be paying a small subscription fee for every month to have access to the data and inject it on your own terms. Or we can also offload the work of deploying and monitoring the relayer nodes, but that's going to cost you extra. But let's say we are not very aggressive in terms of the margin. It's just the cost of deploying the servers and the monitoring architecture. So there are two models. One is like a small commission on the protocol fees. The second one is like a fixed fee for the data availability.
Like also maybe the bottom line. So the costs of running like our Oracle is so much lower that we don't necessarily like need that much of subsidization from ecosystems that we deploy to. And also, as we mentioned, it's more like dApp specific. So we live in an omni-channel, like omni-blockchain world. And if you're in the developer, you're thinking, okay, I have an idea for a dApp. Should I deploy it to Avalanche? Should I deploy it to Arbitrum or any other ecosystem? So of course, you look on the specifications. And imagine like the specification of an Oracle doesn't fit your needs. So then you can come to us and like discuss it for sure. Because otherwise, I mean, it's just like, I would say, the different approach to thinking of like who should be the target customer and also like who should pay the whole flow.
Cool, guys. So we are going to be around in case you got any requirements for some data. So apart from the token prices, we deliver also data for commodities, stocks, FX currencies, some data for NFTs, also derivatives like interest rates, etc. We are very happy to discuss, and if you are curious like what will be the challenges involved in integration, we're also here to explain you like step by step what's necessary.
Thanks a lot.